Okay, so now we're going to add and subtract radicals, and in order to do that, just like when you're adding and subtracting like terms, you have to have certain requirements that make things like radicals. So here, radicals that are going to be alike will have the same index and radicand. So index, remember that that's the little number that's inside that radical part, and then the radicand is actually what's under the radical symbol. So here. So if they're not already identical, then you would have to make them identical. So here in this first problem, we have like terms because we have both fourth roots and they're both tens inside the radical. So all you're going to do is pretend like you have a 1 coefficient here and then add 1 plus 7 to get 8 fourth root of 10. Now it's always a good idea to make sure that that radical is simplified and the fourth root of 10 doesn't simplify anymore, so that would be your final answer. So if we move on to example B now, we have both cube roots, which is good, but then we have the cube root of 81 and 24. So since those radicands don't match, we have to go ahead and break them up. So this 81 we're going to break up, we're going to simplify to become 3 and 27. 27 will become 3 and 9. And 9 will become 3 and 3. So if you remember, when you're simplifying radicals, we need 3 of the same. So I've got 3 3's there. So that means 1 3 is going to come out, and it's going to multiply with that 2 that's on the outside. So I'm going to end up with a 6. So 6 cube root of, and then this 3 right here, that stays inside the radical. Well, then I have minus for my problem, and now I'm going to simplify the cube root of 24. So that's going to become 3 times 8. 8 is going to become 2 times 4. 4 is going to become 2 times 2. So I'm looking for those matches, those groups of 3. So I have 3 2's. So that means a 2 is going to come out of the radical. There's nothing for it to multiply with. So we're just going to have 2. The cube root of, and we can see that we were left with a 3 inside. So now when I look at both my simplified radicals, now I have like terms, the cube root of 3 and the cube root of 3. So all I'm going to do is subtract 6 minus 2 to give me 4 cube root of 3. So these last two examples, we're doing the same thing. Now we've just incorporated variables into the mix. So you're going to want to simplify, make sure that inside the radical, the numbers, the letters, and the exponents are all going to match. So I'm going to go ahead and break up this z to the 5th into a z cubed and a z squared. Remember, we're trying to get the highest number of whatever this index is, so the highest amount of groups of 3's. So what that's going to allow me to do is bring out one z with the 12. So now I'm going to have 12z on the outside. And then I'll have the cube root of 2. I couldn't do anything with that 2, so that has to stay. And then z squared. This z squared right here has to stay inside because that index, or that exponent, is lower than the index. And then I have minus from the problem that was given to me. And then I'm going to go ahead and simplify the 54. So the 54 is going to be 2 times 27. 27 is going to be 3 times 9, and 9 is going to be 3 times 3. So I'm looking for those groups of 3's. So I've got 1 3 that's going to come out. Then I still have that z that's on the outside. That was in my problem. And then inside the radical, I'm left with this 2 that doesn't have any pairs. And then I still have the z squared that was given to me. So inside I have 2z squared. So now we're going to be really careful. We're going to notice that inside the radicals, I've got 2z squared for both of them, but I also need to check that outside I have like terms as well. So I have 3z and 12z. So those are both like terms as well. This is giving me the green light to go ahead and subtract. So my like terms just means I'm going to do 12z minus 3z to give me 9z, and then keep my radical how it is, the cube root of 2z squared. Okay, so last problem here, I'm going to go ahead and simplify both of the radicals, hoping to make the insides and outsides match so I have like terms. So I'm noticing that I have the fourth root of 5s to the 7th v cubed. I cannot simplify the 5, it's just a 5 and a 1, so there's no groups of 4. S to the 7th will break down, so I'm going to go ahead and change that into s to the 4th and s cubed. That's going to allow me to get that group of 4 that I'm looking for to match the index that's given to me. So since I have one group of 4, that means an s is going to come outside and join the 10. s and v squared that's already there. The order doesn't really matter. You can have 10 v squared s if you'd like. So now inside my radical, I'm going to leave the 4, the 5, the s cubed that's left over, and then the v cubed. So now I know I can't simplify that v because 3 is less than 4. So now I want to go ahead and look at my second radical, the 80s cubed v to the 11th, and try to simplify that 80 to get some sort of 5 inside. So since I know that I want to get a 5 inside because I need it to be like terms with this first radical, I'm going to go ahead and divide that 80 by 5, and I'm going to see that I get 16. So you can kind of know that that 16 better be a perfect fourth root because I need to be left with just a 5. So you could go ahead and type that in your calculator, the fourth root of 16, or you could go ahead and break that up a little bit more and break it all the way down until you see that we do in fact have 4 2's. So that means that this is going to become a 2 on the outside. We still have that s on the outside, and then we're going to be left with a 5 on the inside. Now we're also going to be left with that s cubed that's on the inside, and we have to try to break up this v to the 11th. So thinking about that v to the 11th, I need groups of 4. So that would be v to the 8th and v cubed. That means this v to the 8th here is giving me 2 groups of 4. So outside of the radical, I'm going to get a v squared, and then inside my radical is going to stay 3 v's. So now that I've simplified both pieces, I have 10sv squared, the fourth root of 5s cubed v cubed, minus, from my problem, 2sv squared, the fourth root of 5s cubed v cubed. So I've just kind of rewritten them, and this is going to allow me to check and see that inside both of my radicals they're exactly the same, and then I also have like terms on the outside. So once I've got like terms inside and the outside, I can go ahead and subtract the 10 minus 2 to give me 8sv squared, the fourth root of 5s cubed v cubed for my final answer.